5, building successful AI strategies and aligning your business with the UK's AI vision. Very excited to have you all here. Um, so today we're going to be going through quite a few complex topics, to be honest, um, as we kind of uncover what's going on in modern AI, as well as the UK's AI strategy, what that means for your business, how we can best prepare for it, and everything else that comes along with it. We'll do a first whirlwind tour, and it will very much be a whirlwind of modern AI and recent developments, probably over the last 25 years. We're going to go over some performance metrics and some economic realities that are very recent over the past few weeks in terms of what's that meaning for economies worldwide and where the opportunities currently reside. We're going to have a look at what the UK AI strategy talks about and the details that we can gather from it and what we can kind of expect from the technical sides of things. We'll then also go into then a AI strategy playbook, which should be a bit more of a detailed alignment of what you should roughly be looking to do and how we can roughly align as things progress. And then last of all, we're going to go through some regulation certifications, and these are also very new. We'll be doing this in much more detail at our webinar next month, where we'll be going through specific certifications that are relevant, but we will just be touching on them today out of interest around what we're looking for in this development. At the end, we'll always leave time, of course, for a bit more of an open forum of Q&A. So before we kind of get into the meat of it, a few house rules. So first of all, the session is being recorded. So if you want to share this afterwards or have a look at different sections of it that are relevant for you, please do that. There should be a link that is shared around afterwards. So don't worry about that too much. You'll notice that as you joined Google Meet, you've probably joined as a viewer. So that means that your microphone and camera are disabled. So normally a really good idea just to sit back, relax, take in the content. We're going over some quite complex topics today, so I certainly also recommend just put do not disturb on or put the phone away with the screen down, just so you can really get involved and really take it in. As I briefly mentioned, we'll have a Q&A at the end, and of course we've started this series this year and it's been going very well. We've had amazing feedback. We will send a feedback survey around later on. It just helps us know if you'd like more information on various topics, or gives us better direction if you don't like the format as well. Something that's very important to me. So if you do get a chance, please do just give it a bit of feedback. So who is this guy who's talking in front of you? So I am Adam Lyth. I've spent the last 13 years in technology. I specialize in helping companies launch successful products and driving business growth with things that actually matter. So a long time ago now, but I have a master's degree in mathematics and computer science, and I've been working with AI and cryptography for a very long time now. We have partnered with specific investor groups, and you may have come from those investor groups today. And we're here to kind of help make technology simple. And we also have helped secure funding and kind of help companies unravel the mysteries of what technology sits in front of them and make it a little bit simple journey for them. I've supported many startups through multi-million funding rounds, high-profile acquisitions, including Apple, and I'm a very big advocate for tech for good. I'm a big believer in impactful technology for the right reason. We work with lots of charities and conservation efforts, especially in the data and AI space there as well. So if that is also your jam, do get in contact to give me a message as well, because I'd love to hear what you're trying to accomplish if it is in that remit. This is a little bit about my team as well. So we've got a little office in central London, but you'll find us working worldwide. So there's a photo of me down here helping a sea turtle conservation project out in Jamaica. The hawksbill sea turtle, which is one of the critically endangered sea turtle species, which we're using data and AI to try and rejuvenate out there as well. So yeah, it's a big passion of me and my team. So we're going to dive straight into a whirlwind tour of modern AI. So let's kind of jump in from the beginning. And it's a bit of a hazy beginning, if I'm honest with you. So back in 1997, the world was kind of taken by storm a little bit. It was in all the newspapers, it was in the media, whereby a computer finally defeated a chess grandmaster under tournament rules, which was kind of unheard of. Nowadays, that is, stockfish and everything else to do with chess is completely common. But back then, it was a real turning point under the understanding that computational power and assessing position with models with Deep Blue had a big turn of events in 1997 to show that there's legs in computers to potentially be better at humans at not necessarily problem solving, but also much bigger than that, complex games. I say this isn't really an AI model, and the reason for that is because really Deep Blue was a representation of what we'd call brute force. And the reason for that is it's not intelligently trying to construct something. What it's actually doing is checking out all the possibilities of a few moves moving forward and trying to determine what the best move to make would be in that case. And that doesn't really fit under that umbrella, but it does in the context that we're going to move into in terms of computational power and how that's helping us move forward. So the biggest, or the next one probably, is AlphaGo, which was 2016, if you can believe it, maybe 9 years ago. And Go is a much more complex, many more options game, where it was seen to be much more challenging to compete in Go computationally, just because of the not necessarily exponential nature, but massively more complex nature of the game itself. This was Google DeepMind. So this was one of the first AI neural networks based on reinforcement learning. And the idea was that it could study from historic games, it could play itself, but it could ultimately, with a mass amount of computational power, create an artificial intelligence which was able to not only beat one of the greatest Go players ever to exist, but also change the game forever, where it had moves which completely dumbfounded the entire Go community at the time, because it was making moves that people had never seen before and playing strategies that people had never seen before. So a huge step up in innovation by Google. And yeah, it was a real great turning point as well to think that given the amount of resources they put into it, just a huge amount of innovation and power in that problem solving space again. But the gap between Deep Blue and AlphaGo is about 9 years. So you can see how these timings are starting to get eliminated. We'll kind of go into that a bit later. Now, the other probably biggest historical point before the world we're currently in now is probably AlphaFold as well, where a big issue, which you may have heard of because it's been in the paper a lot, is protein folding and protein structures. And the challenge with protein structures was that different types of proteins, based on their size, are charged, so positive or negative. So they would fold in various ways, and they had to have certain alignments of protein to be viable. And it used to be exceptionally difficult to construct proteins, to the point where people were only coming up with new protein structures maybe around 20 or 30 a year. And AlphaFold was again another neural network where they were able to train it on historic protein structures, and it was able to, I think, within a very short amount of time, produce millions of protein structures, to the point now where it's almost critical use of technology in that medical space. Even during COVID-19, it's been grounded in the invention of the RSA vaccines for COVID. So huge step forwards in not just problem solving, but in recent years also huge practical elements, real world impacts, drug development, genetic research, and fascinating story as well. If you've got more time at some point to go into it. So if we go forward a few more years after AlphaFold, we end up in November 2022. ChatGPT 3.5, and it has the most fascinating launch story and fascinating level of benchmarking as well. So we'll go into how this works on the next slide, but in November 22, ChatGPT 3.5 launched. I imagine nowadays it's a key part of people's day-to-day and how it works. But essentially, it ended up being so useful that they had 1 million users within 5 days. It's probably the fastest growing platform to exist in technology. And it's taken AI and the level of how we measure AI by storm in that sense as well, because it's difficult to benchmark what we would call large language model, where the model is there to predict essentially what the next word is to come up with an answer. And what I've done here as well is I've naughtily put a photo on from DALL-E, which came again in that November 22 period, but that was a big leap forward in terms of AI diffusion models. But if you just have a look at what I've taken from the snippet of the ChatGPT white paper that was released, what you'll notice is that some comparisons between GPT 3.5 and GPT-4. And nowadays, if you go to most model websites, they're going to have some level of comparison against human-driven benchmarks. So, for example, if I just have a look, I wonder if my marking is going to work, but if we have a look down at the bottom here, you'll see leak code, which is a type of computer programming test, which some people give to, I don't know, people during interviews to figure out if they can code in different ways. And what you can see is that the score, getting 12 out of 41 on the most easiest testing, is relatively poor, but the differences between 3.5 and but GPT-4 is increased by quite a bit and starts to become viable. And what you can see at these earlier versions, if you did use it, is that it was exceptionally good at things like history and anything where it had information around like psychology or written texts. And a big part of the theory back then was largely because the corpus of information it was gathering from the internet for training was that, really. Boards of text of opinions and history and facts that it could kind of regurgitate in a specific way. And what people would generally say is, oh, it can't think, it can't code. And although that is correct, what we can see is that newer versions of models are doing much better at things like mathematical reasoning, as well as even like computer programming and everything else in between, really, especially like written subjects such as law. Yeah, very, very fascinating. So what people found with GPT was it's useful, but it gave people warnings, right? It's going to hallucinate. Maybe everything that it gives you isn't correct. And especially with DALL-E, people had some luck being able to generate images. But what we see nowadays is that it struggles to do things like fingers or legs. And there's still kinks in the system which make it not as useful. But the rate of progression is quite staggering. So what I'm going to do now is move on to the next slide, where I'm briefly going to go over how neural networks work. And it's hugely important in understanding why these models are getting better in different subjects and what it looks like as we move forward. So please bear with me as you have this very scientific view of, well, computational biology almost. So if you have a look here in type A, we have a cell in the human body and most animals' bodies called a neuron. And the idea of a neuron is that on the left-hand side here, you end up with connections or inputs of electrical signals. It goes down the body and it will ultimately, at the other side, produce other electric signals. Now, the human brain is estimated to have somewhere around 100 billion neurons. So the idea is that as you go down to point C here, you end up with connections between neurons. So an electric impulse, which is produced by seeing something or someone touching your hand or some sort of sensory information, or just, I don't know, dreaming or thinking, has an electric impulse or signal across these cells throughout the brain. And this is how our memory is stored. This is how we think. This is how, we speak, and you're observing all this information now. So in computer science, we decided to try and copy this. So on a neuron level, which is this little figure up here in B, We kind of copied the cell. So the idea is that we have what's called an activation function in the middle and inputs. So we pretend that there's electric signals coming in. We make a decision about how we want to process those electric signals, and we output an electric signal, which is like a sum. Potentially, it could be as simple as if there is any of these which are activated, continue to activate. It's a little bit more complex than that in reality, but the idea in general is how, if we scale this up similar to a human brain, how can we connect these neurons so that if we give it an input, such as text, such as we give ChatGPT a question, how can we get an output? In this case, it would be trying to predict what's the next word that is the most suitable. And what we find here is that the neural network will go through a big training regime. And ultimately, the training regime is trying to figure out which neurons should sit in the middle and how should they be connected. And ultimately, what we're trying to do is not replicate the human brain, but learn from the human brain to figure out that if we have inputs, how can we get suitable outputs to a satisfactory level so that it's predicting something good. So the reason why I think this is important is because I want to briefly talk about like power scaling, because it's crucial to understand just that little bit of foundational knowledge for how these companies are operating, what the models look like, where we're going to go, and also like why that UK strategy is relevant and what it means for you and your business. So again, I appreciate this looks a little bit super researchy, but what we end up with is, for a neural network, is you grow it in 3 ways. And ultimately, you've probably heard somewhere around that, like, the more data you throw at something, the better it gets. And that is somewhat true. But there's actually 3 variations of improvement within a neural network. And they have to be scaled together to get results. If you just scale one without the others, then you actually end up with sometimes quite negative results, actually. So what you'll see is the power scaling rules here. So you've got 3 ways that you're able to make a model like ChatGPT better. The first way is you throw more compute at it. So the idea there is that you have more computer hardware, or you have bigger data centers, or you run it for longer, or you throw a bit more energy at it. And ultimately what that's doing is trying to either create a bigger network with more little neurons inside of it, or it's trying to spend more time trying to weight everything against the test set. The middle one you'll see here is data set size. So the bigger the data, the more you can test against, the more you can learn from. It kind of works that way. And the parameters is a little bit of a more difficult one to explain, but you can think of it as, on the previous slide, like the connections, if you will, between the neurons. So what we find is like the more connections between everything, the bigger it is, the more data we can use to train it, we're actually getting the better results here. And that's what you'll see on the y-axis, which is test loss. What we really mean by that is the lower the test loss, the better we expect it to perform when it encounters new things. And you can kind of see very clearly that there's a straight line down here. So as you can kind of expect, what we're learning from doing all of this is the more compute, the more data, the more parameters and time and essentially money we're throwing at it, the better results we're getting, which is crazily cool. So just back to the little history bit, ChatGPT came out. It's done all of a sudden exceptionally well. And the proof for investors and everyone else is that if we give it more data, spend more money giving it more compute, spend more time, we will end up with better results, to the point where it's almost equivalent to humans on certain techniques, which is great. And after that kind of happened, the space kind of exploded in a few ways. So the first thing that happened was that compute is the only thing that countries can control. You can't control someone else really having access to the internet. They might already have all the data. You can't control the parameters during training because that's just something that exists. So the first thing that happened was that compute was restricted almost worldwide. So what you'll commonly find is like the US restricted all chip exports to China. because there was all of a sudden a bit of an AI arms race, which is who can make the biggest model the fastest with the best results. And the secondary thing that happened, it happened a little bit before November 2022, but these big companies, the big tech giants, started to lock down their methods and information of how they were training these things and how they were advancing these things. And you can't blame them on one hand because they've just spent billions of dollars trying to train and get a certain model. You wouldn't want to just release that to the public so that they can copy it very easily. But at the same time, it does go against that principle of a fair internet and open playing field, things like that. So I would say these are potentially the 6 big players right now. OpenAI is, of course, backed by Microsoft. Elon Musk was originally on the board when it was founded. The whole point of OpenAI was that it was supposed to be an open source model of shared information for humanity. Of course, it's really not that anymore. It's locked everything away. It doesn't release any information when it updates. All these companies are kind of throwing as much money as possible at data center information to try and make the next big model. And all you hear in the news every week is maybe one's leapfrogged the other before the other one figures it out. But all fascinating, but all also backed by basically tech giants. Because OpenAI is essentially Microsoft invested huge amount of money in via Azure infrastructure. Google used its existing resource from when it did things like AlphaFold, DeepMind to try and build up to Bard. Meta was a really interesting one because they have been able to harvest all data from Facebook, Instagram, and arguably WhatsApp as well to train its model Llama. And they are probably the ones who are the most open, but they still are very tight-lipped about inner workings and inner training items. Anthropic was an ex-OpenAI researcher, which is invested by Google. So you might have heard that Anthropic in the news recently because they've just signed an agreement with the UK government under this AI strategy. And then more notable AI resources as well is that there's one with Tesla Twitter called XAI. The idea there that it's supposed to be trained from both Tesla's information from the self-driving vehicles as well as Twitter's. And of course, there is a Chinese comparison as well called Baidu, although I've not heard as much to that one. But I would say 2 months ago, this was the playing field. You had all these huge companies. It was completely closed down. You couldn't really get in the door. Everyone was trying to protect their own secrets, and the advancement was relatively straightforward. And then a bit of a bombshell went off, I would say, maybe 2 months ago, called DeepSeek. And this was relevant for a few different ways because it shook up the industry massively. The first major shakeup was these were the first guys to publicly just release everything. It was completely open source. They implemented reasoning like you see in OpenAI versions, which is seen to increase results even further. But these guys just laid out exactly how they did it and how much it cost them. Not only that, but they came up with alternative methods, what we would call like algorithmic improvements in some ways. And they completely kind of shattered this reality of it's only for the big guys. And all of a sudden, after they released this paper, it was like anyone with a decent cluster could all of a sudden be in the game a little bit. Anyone could pull the model and just use it locally. It was a huge role in like democratizing that AI model. And we're in this bit of a weird space now where we're still seeing the recoil of the effect of them doing this. And the geopolitical tension as well is crazy because, as I kind of mentioned before on the previous slide, the only lever countries had to pull was like restrict chip imports to slow other countries down. And this kind of shattered that to say you can export it, you can put export restrictions all you like, but within 6 months or within a year, let's say, we can get close to the nearest model and publicly release it. Depending on which hill you stand on, that's either positive or negative, but for a business sake and an innovation sake, absolutely amazing. Because now what we're seeing is a much more level playing field of training. And here's just an example of, for example, how much it costs to do cost of reasoning. like you don't have to pay a king's ransom to do this anymore, right? You can take a pre-trained model, and now what they're doing is adding additional steps at the end to increase accuracy. And there's nothing stopping like startups from doing this now anymore, which is incredible. Now, I was just going to put a quick poll actually before I continue on to the next stage, which I'd actually like to just get a little bit of an idea of how often people are using LLMs at the moment. Um, because what the next section is the economic reality, which is we've actually got some data to show what it's being used for and why. I'm just going to let you do that for a few seconds if you don't mind giving it a go. Okay, we got a little bit of a mixed bag, which is really interesting. So very extreme, actually. So on one side, we've got people using it multiple times a day, which I'm kind of in that category as well. And then the other side of it, we've got people just using it maybe once a month, which is on a much lower scale, which is kind of fascinating. So that's the brief history of AI. What I want to dive into now is more of like what we found now. I mean, it's only been from the end of 2022, so we're talking about maybe like 2.5 years, 3.5 years that it's been out for, and people have these models have been accelerating. And I think what we're now trying to figure out is there's a lot of fear mongering online of like, will it affect people's jobs? Is it beneficial? What is it good at? What is it bad at? And this is kind of what I want to present to you a little bit today to see where are maybe the opportunities and what are maybe the realities that are going to come to light over the next couple of years as we do continue this development and kind of ride this wave a little bit. So one of the things these companies have started doing, so this one is from Anthropic, it's a fascinating read, is they've started to do what they call an economic index. And what they're doing is that they are taking every single person's prompt that they're using inside their system, and they're trying to categorize it into what it's being used for, if it's being successful, and what level of automation that person might have expected or not. So here are the top 6 categories which LLMs are currently being used for. So as you might expect, because it's a little bit of a computer science field, and nerds like me who like to code and do all sorts of maths, computer science are normally the first advocates for it. We're kind of in that number one position. And what we're finding is that it's mostly being used by computer programmers and software developers to maybe like debug information, to help develop and maintain those like software applications and websites, or even to do like minor like database work and things like that. What's most surprising, I think, not now, but maybe a few years ago, is that the promise of AI was supposed to be, oh, AI can do all the boring stuff, and then we get to do all the fun stuff. And then we'll be creative, and that's our job. But actually, that's not necessarily what's happening. So, because in second place, we're actually finding that art and media is the second biggest use case, whether that's like copywriting or technical writers or editing anything to produce information for like scripts for TV or even like video or photo content for it. And I think even today, if you look in the news, like there's a big artist strike again where they've released like a blank album with nothing on it because there was the very famous writer strikes in LA as well for this kind of effect of, we're potentially replacing writers, copywriters with jobs by this quite early. And then just to go over the others very quickly, we've got education in the third place, where we're finding that like tutors are using a lot, or teachers are using it a lot to design like lesson plans, or potentially even like, give students a more bespoke curriculum based on their needs. We're finding it a lot outside of that in like office administration, maybe like the social sciences as well, in terms of being able to conduct research findings or giving it loads of data and trying to analyze some results. And last of all, of course, maybe like business and financial side. So like budgets, financial advice, educational advice, and then back into that business side of data. So super interesting to see the poll. I'm not sure if you put yourselves in one of these categories, if you do use it multiple times a day. but super interesting. I think it's more super interesting when you start to look at like the performance of the percentage of conversations against like salary-based stuff as well. Because what we're actually finding is the major part of what AI seems to be augmenting or automating is in this like early wage bracket where we find people such as like software developers, computer programmers, or maybe like copywriters, tutors, teachers, where it's doing a large part of that work. But when it comes to things like medicine and much more complex topics for people, that's where it's not being adopted as much. And there is qualms in the data to say, is that because um, they're not using it as much, or that they don't want to use it as much, or is it there's not enough data around what they do, or is it a training element? So it's all with a bit of a pinch of salt, this data, but it's interesting, at least at this stage, to see how things have panned out over the past couple of years now. And then from those tasks, what we're seeing is that I think it's around 45% of tasks from Anthropic, at least, could almost arguably be almost fully automated. So this is whether they're providing it with little feedback and it's adjusting what it's doing to come up with the correct results. And then augmentation is where there still requires to be a human involved on a higher level, where it can enhance that person's job or enhance that person's performance in some way. And these are the two little buckets we're seeing around that. And I think this is the most interesting as well, because it probably reveals if you are in business, or if you do have a business in any of these areas, it's a great indicator to show like areas of potential opportunity and replacement within what you're trying to offer to people. So this kind of moves on to like, that's the status quo. And I realize I spent a long time talking about it. But the next question is like, the UK kind of revealed their AI strategy. So why are they doing that? And what do what does an AI strategy have in place in the first place? So going back to these graphs, I think what's important to know is that if you want to compete on this level now, on a government, huge, big tech level, you have to increase these three things. You have to increase your compute, you have to increase the data set available, and you have to increase the parameters of the model that you're producing. There's no kind of two ways around it a little bit. You either use someone else's model who's done this, or you kind of start producing your own. And what we can see from models over time, and what you'll see here is like, for example, I've mentioned AlphaGo. I've also mentioned DALL-E here. I've mentioned GPT 3.5 isn't on here, but GPT 4 is, as well as Gemini Ultra. What you can kind of see is this is how much money is approximated they've spent to train that model, and roughly when it's happened by. You can kind of see there's a little bit of a linear graph where we're seeing the cost of training these models is increasing by about 2.5 times per year. But of course, we're also finding that the results that the models are producing are much better as well. So early on, we're looking at maybe 1 million to train AlphaGo, and now we're up on this logarithmic scale to somewhere around, I don't know, 60 to 70 million per model. But progressing this forward, you're going to see, very shortly, we're talking about billions of dollars to train a single model. But this is the trajectory we're going on, and that's kind of important to keep in mind. And the other roadblock when coming up with a long-term strategy is the fact that I mentioned compute, data, and parameters have to increase, and you have to kind of increase them all at once. Well, the data is running out, and it's estimated we're going to run out of it around 2028. So they're estimating at the moment that we should have like PhD Nobel Prize level AI models in the next few years. But the caveat here is also we're kind of running out of time, where at this stage where the lines start to meet is the stage where we're not sure if performance is going to increase or if we're just going to hit a wall. That some people are hoping for like general artificial intelligence, but there is an argument to say, is that we don't know if that's realistic. So this is kind of what the UK government has to consider. Now, what they have said is that for this next phase of AI development, they want Britain to step up, and they want to shape the AI revolution rather than seeing how it shapes us, which is kind of how it's currently going, to be honest. What we're seeing is like the US and China having these huge models, and the UK is kind of falling behind a little bit between the gaps. But yeah, the DeepSeek revelation is quite a net positive, I would say. So AI strategy tries to prioritize three things in the UK. The first one is investing in the foundations of AI. And what they really mean by this is that they want to produce sovereign compute. So huge data centers that UK businesses don't need to have, the billions of budgets to train against. So that around the UK, I don't think they've announced it yet, local councils can apply to kind of be involved in like growth zones or data centers. The idea is that they're going to start creating these huge data centers that allow startups and companies to use as you would in terms of a grant. So in the same way that Microsoft, for example, invested in OpenAI in terms of giving it free resource on its cloud platform, the UK is trying to have AI data centers around the UK where startups or bigger companies are going to be able to take advantage of, recent chip breakthroughs, recent compute power to try and come up with models which are going to benefit, everyone, public and private businesses. The second one is that they're aiming to change lives by embracing it better. Everyone knows the public sector kind of moves very slowly, especially if you think of like NHS and technology. But they're looking to try and use the recent advancements as well as any new advancements moving forward, where private companies can tender anything they're doing to prove that they can increase the productivity of what the government's doing, as well as providing a good foundation for private companies just to sell these models or sell the software or sell an API to help the productivity kind of lag that currently exists. And the last thing they are aiming to do is to kind of position the UK to be a bit of an AI maker. And what they mean by this is that because there's restrictions globally, there is a race to try and get to the bigger models, the ones that are more successful, the ones that are going to be better for everyone. And there is some geopolitical evidence as well to show that you can like introduce bias into things like ChatGPT and how it responds to people or citizens. So there is also like a national security side to say we also need to be at the front of this in some way to make this beneficial and safe for people. So what does that actually mean? I've jabbered on about neural networks. I've jabbered on about what's happening. I've jabbered on about where we're going to move forward. What does it mean now, looking forward for the next 5 to 10 years for businesses trying to do this, and what can we kind of expect? So the first one is that the AI research resource is increasing by about 20-fold, which means what we're probably expecting, as you'll see in number 4 as well, is that there's going to be an absolute spur of funds, grants, incentives. There's going to be a huge amount of opportunity to finesse existing models, where we can take these big models that have been trained for billions and fine tune them for reasoning for actual software. So an example of that might be, I don't know, creating a chatbot off the back of something to help a business, or automate office documents or processes or anything along those lines. The second biggest one is data. We're going to get into this in a little bit now when we talk about AI strategy. But the UK government is looking to open a national data library. This is supposed to be public, although I'm not sure if some of it's going to be private and some of it's going to be public based on what they're looking to share. But a big part of trying to get started, and a big part of trying to create something which is much more bespoke, is having the data to also be able to either curate it in the first place or fine tune it for a good use case. So having public data sets and having that power of data is really going to help companies like yourself bootstrap whatever you're trying to do to make these new models, the new bits of software. The third bit, which might be super relevant if you hire staff, is that scholarships, fellowships, more degrees. There's going to be huge incentives to try and bring researchers, especially in the space, to the UK, to train universities, and for companies to have partnerships with those universities to move forward. And of course, point four as well, which is there's a lot of money going into this, a lot of money tied to what we're calling growth zones. So what we're probably going to find is like local councils and local areas are going to end up tendering for these huge data centers. And then on top of that, there's going to be grants to potentially use them or get involved in some way, or potentially just grants to allow you to train your models off the back of it. So this is really what we're expecting. The details are still very light and it's very early on. What you'll largely see right now is them tendering for these big data centers and for companies to build them. And I think we're also seeing like local councils bidding to be growth zones and also bidding to be, part of this strategy. So we're still a little bit early on in terms of what it's going to look like, but this is the future of probably the UK strategy. And I hope this kind of explains how it's aligning with how AI is developing as well. More compute, more data, better results, and how can we then use that to make it productive and make people more productive? Because there's clearly signs that people are using it, and there's clearly signs that there's potentially great levels of automation to move forward. So we're going to move on to kind of the next section now, which is how do you prepare for it? Or how do you launch a product now? Or how do you prepare to bolt on a product that you want to use AI with? So I see this in 4 different sections. First section is data and actually trying to figure out what you're trying to achieve. I can't emphasize enough that you have to start with a problem that you're trying to solve. I think if you're starting with a solution and trying to find people who have that problem, it just never works. Having a clear idea over what you're doing for people and what problems are you saving them time, are you saving them money, are you automating a system, are you saving a company maybe staff salaries? So first, define your problem. The next thing you have to consider is what data you have. Because I've worked in AI for a long time now, before all of this has really kicked off over the past 5 years. Maybe like 8 years ago, I would say most AI startups would fail because there was a chicken and egg situation where they'd have a startup and they'd have money, but they'd have no data to do anything, to create a model. At the same time, they have no customers to collect data. So what we often found is most of the companies who are AI startups would not be AI at all. They would probably create a product and potentially lie or twist the truth slightly to gain data, with the aspiration that they'd maybe switch AI on at a later date. But now that's changed a lot. Nowadays, in more recent years, the software element doesn't matter. We can piggyback off of existing models. The real difference, the real value we're providing as a business to people is the data that we have, the data that we collect and what we do with it. And I think this brings me on to the last point here, which is not necessarily just about the data we're collecting to solve that problem. It's also, we need to take a step back and figure out how we're going to improve it at a later date. So a good example of this might be that you are collecting people's information so you can provide a custom experience to, let's say, I don't know, shopping recommendations. So you're going to have a look at like what they're browsing, how long they're doing, things like that. If you don't have a measure of if it's going well or not, it can kind of hinder you in the long run. So what you might want to measure, for example, is are they actually purchasing products? And like having that data, for example, if you're an affiliation website, let's say, and you're sending to different links and you're not collecting the data where they're converting potentially, could seriously hinder you in the long run, because maybe you're optimizing for their clicks and you should be optimizing for sales, right? So it's really important to just sit down and figure out what you're trying to achieve, what data you have now and what data you're not collecting, and what data you might be able to collect based on what you're trying to achieve. So that's step 1. Step 2 is you've now got your data. you've got a strategy of what you're trying to achieve. How will you achieve it? And this is where we kind of use, it's not an industrial term, it's a term I use a lot. It's called a warm start or a cold start. So a cold start is the traditional method of doing it. It's where you build your big data set, and this happens especially in like professional firms. If you think like law firms or accountancy firms or I don't know, big oil or something, probably have data going back to the 1990s, very thorough, very kept. They have these huge data sets where they can potentially use modern techniques to create something brand new from scratch. And you would go and you would potentially, create a neural network or experiment with various other models to see if you can get the highest accuracy of what you're trying to achieve. The other side of it is what we call a warm start, and this would be as if you were taking like ChatGPT and you're bolting on your information on top of it to try and then produce a product. And we call it a warm start because all the hard work's kind of done, the engine's been running. We're purely using it to throw our data in and then trying to advance to a solution. And what's important to remember at this stage is that if we go down that development route of a warm start, something we call loosely coupled architecture is more important than ever. And what I mean by that is like if, for example, the car on the screen, you should be able to change the car's tires easily. In the same way, because these models are improving so drastically and so quickly, whatever we build, it's important that if we have a warm start, we can take away an old model and put another one in. Because what we're probably expecting to see is that the cost of running these models might increase, but it's not going to increase that much. For example, DeepSeek producing a year later for a tenth or a hundredth of the cost what OpenAI did a year ago, but for greater results. That's the sort of thing we need to prepare for now when we produce an AI model. So when I say loosely coupled architecture, I mean modular swappability is key. Because when we produce this model for the first time, it might have the most current AI model right now on the warm start, but the ability to then swap it out for something new and seeing how it affects the accuracy is really very important. And I think the last thing to consider in your development strategy is your data pipeline and security as well. So it's very important that even if we're on-prem or cloud, it's important to think that you have an option between using an API. And I mean that by you would just take a key from like OpenAI and you would send the data to them to get information back. Or the alternative is having a bit more of a self-hosted option where you're taking the smaller models such as like DeepSeek or something on less compute power, and you're having that on a private instance. And it's important to consider that because security is becoming more important than ever. You're not necessarily always in an industry where you're allowed to send that data to America or you're allowed to send that data to any other company. So it is important as well to think about how you're going to kind of launch that model. So you've got your data, you've figured out if you want to do a warm start or cold start, which is your product, and you're getting good accuracy results against it. What do you need to do next? You need to deploy it and you need to iterate. Now, almost all AI strategies benefit from what I'd call a hybrid rollout strategy. And the idea there is that you would first release it to maybe like family and friends or close customers, 1%, and then 5%, and 10%, and 50%. And you keep increasing slowly to roll out the system. And it's extremely beneficial in that way because what happens is that customers never really will know as the AI increases in accuracy. So what I like to do is maybe compare this to like Deliveroo. If you order a burger or something to your house, there is an AI algorithm that sits behind it that decides which driver it goes to based on their rating, their information, where they are, what they're driving. And that will improve probably slightly every single week as they release new versions. But you will never know as a user that it's slightly better or slightly faster, or your food's warmer when you get it as you kind of use the application. And this is what you kind of expect to do when you roll out. You would release it to a few customers first, and it maybe won't be as good to begin with. And then as you learn and you start to gather more data, and you can start to train it even more and more and more, This is how it'll improve over time. And as you release it to more users, you get more data, and it kind of spirals like that. And that's roughly how you would deploy an AI models. I say almost, because there are exceptions, of course. The important things to consider at this stage is, how do you know it's succeeding? And how are you measuring that performance? So in my Deliveroo example, you would say, are people getting their food on time? Are they getting good reviews? Are they returning, maybe? And there will be a use case on a business by business cases to see, is it doing its job properly, and how can we measure and improve that score over time? And last but not least, you also have to consider safety and laws. So, for example, what you'll figure out on ChatGPT is that sometimes it'll say, I'm not allowed to provide you information on that topic. And that's because you're potentially having like harmful information, or on the same level, you want, sorry, words. You want to make sure that you're like not revealing other people's information and going against GDPR or copyright laws or things like that. So there is like AI safety to consider. And then once that's kind of rolled out, you do have to be future looking. And this is where it's important to really stay on top of it. We need to keep on top of the models and how they're performing. Can we swap them in for better results? Can we keep up with new developments to improve over time? Are there resources available to us? Are there like local councils with incentives that are going to give us money to improve the product or use it? So it's just important to roughly keep in mind what's happening. Now, the biggest scalability companies often go through is that they might start in the UK market and then they'll head for America. And this is normally a big consideration, but it's even bigger with AI. Because what we find is that like when you construct your data set, there might be bias, it might be controlled, it might be from UK only people. So all of that effort we've gone through to train and have a hybrid rollout strategy and make sure it's okay for the UK doesn't necessarily mean it's going to work for the US. There's different geographies, different cultures, different businesses, different working protocols, different hours. So it's important to also make sure that like we're preparing the data for any future growth or any future business plans to move forward. All right, I'm running out of time pretty rapidly, so I'm going to whistle stop tour through regulations and certifications. This is always behind. Regulations and certifications don't necessarily keep up with industry. There's two that have emerged recently. One is ISO 42001, and the other one is NIST AI RMF. The key thing that these are trying to define, and I think it's a big part in the UK's AI rollout as well, is how can your AI system be trustworthy? It's a big balance when you have a neural network as well, because generally you don't really know what's going on inside of it. And we're going to go into this in much more detail in the next webinar, but there are 6 things when considering AI and launching it at scale. And I think these things are going to come up quite quickly. But essentially, is it valid and reliable? So for example, does it perform consistently well with the same tasks? It doesn't just do your one answer really well, and the next time you go and use it, it's terrible or does the wrong thing. As with most certification things, is it safe? Is it secure? Is it resilient against things like cyber attacks or harm or safety hazards or privacy laws? And then the next ones are really challenging, to be honest. How can it be accountable and transparent about how it's come to the decision it's made and who is responsible for the advice that it's giving? How can the results it's giving be explainable and interpretable? So these two are probably the most challenging that we don't really have a great answer for right now. The next one is privacy as well, just to make sure it's not breaking any laws, GDPR, UK data laws, anything else like that. And the last one, which is obviously a bit more of a sensitive topic, is that how can we manage harmful bias? Almost all data sets have bias. And when we train a machine learning model on that bias, it kind of bubbles through a little bit as well in potentially a negative way, which needs countering. So how can we have ongoing checks within AI models that aren't discriminating or having skewed outcomes, or doesn't affect different demographic groups in a certain way? So these are all the things we're going to be covering next month, I believe, in how we go about doing this and how you go about doing it in terms of certification and onboarding in that sense. But in the meantime, I'm going to leave it there because it's been an incredibly heavy webinar, in my opinion. As I mentioned kind of early on in the presentation, my job and my team's job is to make technology easy and make this easy. We want to make sure that you can run your business and give you the best advice to move forward. So if at any point you do have questions or you kind of do want to take the first step into this crazy AI world that we're currently living in, just get in touch, drop us an email. And, we have completely free consultations just because we want to make sure we can help. So just do reach out. And with that, I've not left lots of time, but if you have any questions, please do, as Imogen's kindly shared there, press the three shapes in the corner. There should be an option to ask questions now. I'll do my best to answer them. All very quiet. So I'm hoping you've absorbed it all. If you ever wanted to chat about the more intricacies, do get in touch with me as well. I could probably talk about this stuff all day long. I do it all day long. Yeah, I'll give it another minute, but if no questions, we'll probably end the webinar there. Ah, so one question is, do we foresee the government shifting strategies now that DeepSeek has emerged? I think it's a really interesting question because the UK announced their AI strategy before DeepSeek kind of blew up. So I think there's always been a rough strategy of the West keeping compute tightly locked and to have a more sovereign AI or big tech AI strategy, keeping models, exclusively for that kind of elite group. But DeepSeek has really blown that up and really just opened the playing field, which is really great news. Does it affect the UK's model? My instinct would be to say no. And the reason for that is because the amount of investment the UK are spending compared to something like the US is a tenth of what the US is spending. So that means, when we have a look at the compute and the performance and the parameters, we're probably at a disadvantage in any case. The advantage really comes from that British ingenuity that kind of brought us Turing and Lovelace, really. Can we make algorithmic improvements now? And can we bring in universities, pioneers, and thinkers to really, shift that cost curve a little bit like DeepSeek has and make sure we can produce models that are not only on par, but exceeding people with much bigger budgets? So I don't think it'll change the strategy as much, but it probably will in terms of who they're going to be allowing to use that compute resource. Question from, do you think most companies will eventually have their own AI platforms? It's a tough question, really. Most companies already have an API. And an API really is an interface that allows you to do something with that business, whether that's buy or sell or get information or publish information and be part of the community. I think what we're likely to see is a bigger movement of AI-based agents. You might have heard the term like agentic AIs, where the idea is that someone using ChatGPT or an LLM or anything would be able to use your platform without actually going to the website and interacting with it. They'd be able to just be like, book me a table at my local restaurants, or maybe like buy the stock for me or optimize my stock portfolio. And you would expect it to start calling your business's AI or your business's API, sorry. kind of do that, or arguably your AI as well. It just sits behind an API. So it's kind of a bit of a convoluted system. I hope that answers your question in that way. Brilliant. Well, I think I'm at the bottom of the list, so I'm gonna call it there. It's just slightly over time as well. If you've got any questions, drop me an email or my team an email afterwards, and we'll see if we can help. Otherwise, have a fantastic day, and thank you very much for your time today. Have a great day.